Welcome to The Debate. So on February 3rd, $285 billion vanished from software stocks in a single day.
Just completely wiped out.
Right, gone. And market analysts immediately dubbed it the SaaSpocalypse. But, what actually caused it? It wasn't it wasn't a global macroeconomic shift or some big regulatory crackdown.
No, it was just a software update.
Exactly. Specifically, Anthropic's release of Claude Opus 4.6 and its new agent teams functionality. So today we are exploring really the defining architectural question of our current era.
Yeah, the big one.
Are we looking at just a neat new tool that simply shifts human labor from writing code to managing workflows? Or did we just witness the permanent, autonomous substitution of the human software engineer?
I mean, look, it's the conversation happening in every engineering boardroom right now. The market reaction was visceral, obviously, but we really need to look under the hood to understand what actually changed here.
Well, I look at the data, the architecture, and the empirical outcomes of Claude 4.6, and I see true substitution. I mean, AI has crossed the Rubicon from this, intelligent assistant you chat with to an autonomous executor that builds and runs entire software systems without you.
Right, and I look at that exact same release, and I see a market severely overreacting to what is ultimately just a new orchestration tool.
Just a tool?
Yeah, human expertise isn't being substituted. It's being elevated to architectural governance. And frankly, it comes with a massive hidden agentic tax that people are really just starting to discover.
Well, let's break down that market reaction because I don't think it's an overreaction at all. It was a structural collapse of the old model. We are talking about a pincer disruption here triggered by the 11 vertical plugins Anthropic launched alongside 4.6.
Ah, right. OpenClaw.
Yeah, OpenClaw. It attacked established companies from both the top and the bottom simultaneously.
The high-end sustaining markets definitely took a massive hit. I mean, LegalZoom dropping 20%.
Thomson Reuters down 16%.
Yeah.
And DocuSign dropped 11%. Even Salesforce and Adobe fell like 7%. But the reason I say it's a true substitution is that it didn't stop at the high-end specialized software. It hit the low-end labor markets at the exact same time.
You're talking about the nifty IT index?
Yes, it tracks the major Indian IT services companies, which provide the global backbone of billable hours for QA testing, data analysis, outsourced engineering. That fell 6%.
Because the assumption is that the AI can now just do that outsourced manual labor.
Right. I mean, think about what's actually happening on the ground. When an agent team can autonomously pull local compliance codes, draft a complex legal document, review it against precedents, and finalize it, it just replaced the specialized legal software you would have bought. And when that same team can autonomously build a data pipeline and run the QA tests on it, it replaced the outsourced human hours you would have billed to test it.
Sure.
It's not a productivity enhancement for the worker. It is the outright replacement of human-designed systems.
Look, the capabilities of Claude 4.6 are undeniably impressive. The sheer speed of execution is staggering. But framing this as the wholesale replacement of human labor, I'm sorry, it completely ignores the operational reality of running these systems in an enterprise environment.
How so?
Well, you're looking at the output, but ignoring the massive friction required to get there, which is what we call the agentic tax.
You mean the compute cost? Like the price of the tokens?
Token costs are a huge part of it, yes. You spin up 3 to 5 independent Claude code sessions to collaborate on a shared code base. And visually, it is amazing. You see the terminal windows flashing as agents talk to each other.
It's incredible to watch.
It is. Right up until the token meter starts spinning wildly out of control. But the agentic tax isn't just financial, it's operational. This system does not operate in a pristine vacuum.
What do you mean by a pristine vacuum?
I mean that in the real world, data is messy, APIs fail, business logic is highly subjective. Claude 4.6 fundamentally requires humans to establish rigorous testing harnesses to govern it.
Okay, but
The bottleneck for software production hasn't disappeared, it's just shifted. It shifted from human keystrokes to token availability and testing rigor.
I think you're...
Take a data engineer, for example. Their job used to be writing the ETL pipeline, right? Extract, transform, load. The basic plumbing that moves data from a messy database into a clean dashboard. They haven't been substituted. Their job has simply become managing the agent matrix.
The agent matrix.
Yeah. They move from writing the plumbing to policing the autonomous agents trying to write the plumbing.
Okay, you say the bottleneck has just shifted to human policing, but that completely ignores what happens when you remove the human entirely.
But you don't remove them entirely.
Look at the C compiler experiment conducted by Anthropic's safeguards team right before the 4.6 release. To me, this is the definitive empirical proof of pure autonomy. Are you familiar with the specific parameters of that test?
I am, and I know exactly why you're bringing it up. But I actually think the methodology of that test proves my point.
Well, let me lay out the raw stats first, because they are staggering. Anthropic set loose 16 parallel Claude agents. In approximately 2 weeks, those agents built a complete Rust-based C compiler from scratch.
Yeah.
100,000 lines of code. 0 external dependencies beyond the standard library. It passed 99% of the GCC torture test suite, which is basically the ultimate stress test for how a compiler handles edge cases.
It successfully compiled Doom, SQLite, Redis, and Postgres. I'll grant you, it is a remarkable technical feat.
It is unprecedented. It supported multiple system architectures, x86, ARM, RISC-V, and it did all of this without a single human keystroke contributing to the codebase.
Okay, but
This isn't just a fancy autocomplete tool finishing your code. This is a digital engineering team that architected and delivered foundational computer science infrastructure completely autonomously.
I'm sorry, but I just don't buy that as pure autonomy. Let me tell you why. Look at how they actually achieve that 99% pass rate. The AI didn't do that in a vacuum.
It wrote the code.
The breakthrough for that compiler project only happened because the human engineers stepped in and set up GCC as an online known good compiler oracle.
Well, yeah, to enable parallel debugging.
Precisely. They relied on delta debugging. If you think of traditional software debugging like a human looking for a needle in a haystack, delta debugging is like a machine automatically splitting the haystack in half, testing each half and repeating the split until it isolates the exact line of failing code.
Right.
The human engineers built this perfectly engineered, frictionless oracle environment for the AI to throw code at. If the code failed, the system automatically helped narrow down the delta.
But the AI was still writing the code to fix the failure.
Yes, but it didn't architect a brilliant zero-shot solution through sheer reasoning. It brute-forced the execution within a meticulously human-designed testing slot machine. It just kept pulling the lever.
A slot machine?
Come on. It's true. And let's talk about the cost of that brute force. That 2-week experiment consumed 2 billion input tokens and 140 million output tokens.
Okay, but
It cost approximately $20,000 in compute. Sure, you can argue that $20K is roughly equivalent to a mid-level engineering salary for a few weeks. But the real cost was the immense human scaffolding required to keep the agents from spiraling into hallucinations. The humans provided the architectural guardrails. The AI just ran the maze.
I see the distinction you're making, but the fact that 16 agents could even systematically use that oracle in parallel brings us to the real breakthrough of Claude Opus 4.6. It has solved the fatal flaw of all previous multi-agent systems.
Which is?
Context rot.
Well, context rot has certainly been the graveyard of every agentic system we've seen prior to 2026.
Exactly. In the past, if you gave an AI a massive, sprawling codebase or a complex data pipeline, by token 50,000 it would lose the thread. It was like asking someone to memorize a phone book. By page 10, they've forgotten the names on page 1.
Right, it would just hallucinate.
It would start hallucinating variables that didn't exist or completely forgetting its initial instructions. Claude 4.6 solves this with context compaction.
And you view compaction as a substitute for human working memory.
Functionally, yes. Context compaction acts like a brilliant executive assistant who sits in on a massive meeting and constantly summarizes the notes in real time. The core agent team never holds the entire raw transcript in their working memory. They only hold the vital, compressed takeaways.
Okay.
Because of that, they can execute over hundreds of thousands of tokens without hitting hard cognitive limits. Furthermore, the agent teams maintain a shared task list. It literally categorizes tasks into pending, in progress, and completed states.
Which requires strict synchronization.
Right. It uses a file locking mechanism to prevent race conditions. For anyone who hasn't dealt with race conditions, it's like two people trying to edit the exact same sentence in a Google Doc at the same time. It creates chaos.
Chaos, yeah.
Claude forces the agents to synchronize through Git integration. They pull from upstream, merge their changes, and resolve their own code conflicts exactly like human engineers do on a development team.
Look, the Git integration and the compaction are technically brilliant. And I know you're going to bring up the Patil effect next, which made all of this actually affordable.
I am, because it's critical. Rahul Patil, Anthropic's CTO, introduced infrastructure optimizations in late 2025 that dramatically improved memory utilization and decoding speeds.
Right.
The Patil effect means this isn't just a $20,000 one-off C compiler experiment anymore. Running always-on parallel agents is now a financially sustainable operational model for normal enterprise companies. The AI achieved a 90.2% score on the Big Law Bench reasoning test. It is cheap enough and smart enough to run constantly.
Financially viable, yes. But let's step away from Anthropic's internal experiments and look at how senior engineers are actually deploying these agent teams in the real world right now.
Okay.
They aren't just letting them run wild. In enterprise environments, teams are strictly using them for AI-enforced TDD, test-driven development.
Where one agent writes the test before the others are allowed to write the implementation code.
Exactly. One agent writes the testing parameters and explicitly blocks the other coding agents until those tests pass. Why do they do that?
To ensure equality.
Because the system is inherently fragile. If left truly autonomous, agents fail in silos. They cascade errors. The open source contributors who praise this system point out that the agents act like a unit, pulling in peers for help.
Right.
But that only happens because human engineers have wrapped them in incredibly strict, predefined testing rules. The main Claude preserves the high-level plan, while the coder Claudes work in isolated, high-precision environments. That isolation is deliberately designed by humans to contain the blast radius of AI mistakes.
But isn't that just good engineering practice? I mean, humans use test-driven development too. I don't see how enforcing best practices negates the autonomy of the system. In fact, if you look at the fundamental architectural philosophy Anthropic is pushing, it is decidedly decentralized and developer-first.
Which explicitly sidelines the human?
Sidelines the human how?
Look at how Anthropic's local scaffolding operates compared to the competition. OpenAI built AgentKit as a product-first ecosystem. It integrates agents into a centralized, managed black box.
Sure, you ask ChatGPT to do something, and it manages the agents behind the scenes. It keeps you in a chat interface. Anthropic went the exact opposite direction. They use a local scaffolding system managed right on your machine in a hidden directory called .claude/teams. And more importantly, they introduced delegate mode.
Oh, right. Delegate mode keeps the human out of the immediate coding loop.
It literally walls the user off. When you activate delegate mode, it explicitly restricts the human to coordination-only tools. It prevents the human from jumping in and writing code. You sit there watching a terminal multiplexer, basically a screen split into multiple panes showing the code streaming by as the agents work, and you can't touch it. When the software explicitly blocks the human from the execution layer, the AI is no longer just a tool in your hand. It is the primary executor. The human is reduced to a spectator.
A spectator? No, the human's job has escalated to something far more critical: security and governance.
Which brings us to the most crucial piece of architecture in this entire ecosystem.
Let me guess.
The Model Context Protocol, MCP. MCP is the very thing that proves my point.
Wait, before we dive deep into MCP, for anyone who hasn't dug into Anthropic's API documentation, MCP is essentially the bouncer at the door of your company's database, right? It's a standardized protocol that dictates whether an AI agent is actually allowed to touch your live data or external tools.
That is a perfect analogy. It is the bouncer. And the reason Anthropic built agent teams entirely around the Model Context Protocol is to prioritize auditability. Yes, delegate mode keeps you from typing code. But why? Because you cannot have an autonomous agent dropping core tables in a production data warehouse just because it hallucinated a schema optimization. Well, right. If agents are accessing production databases, you need strictly typed integrations. You can't just give them the admin password.
Exactly. MCP requires incredibly strict permission evaluation hierarchies. The human engineer has to set up configurations checked into source control that dictate when an agent gets a deny, ask, allow, or default response to tool access.
Right.
If an agent wants to push code to production, does it hit an allow or an ask? The human engineer hasn't disappeared into the role of a spectator. They are now the critical security architect. They have to ensure that these distributed, parallel execution workflows don't autonomously destroy cloud infrastructure. Governance is the new bottleneck.
But consider what you just described. A human architect sets the permissions, defines the infrastructure boundaries, reviews the edge cases, and lets a team of agents actually write, test, and deploy the code. Isn't that exactly what the role of a human engineering director is?
Wow.
If the AI is acting as the entire team of junior and mid-level engineers, the substitution of labor has still fundamentally occurred. You haven't proven that the human engineer is still coding. You've just shown that we promoted the single remaining human to a management role.
It's not just management, though. It is verification. And verification in software is often harder than creation. Anthropic's model features adaptive thinking. It picks up contextual clues to balance speed versus extended reasoning.
Right.
When you are debugging a broken data pipeline at 3 a.m. because customer transactions are failing, you need deterministic, absolute results. You do not need philosophical deliberation from an agent. The human has to verify the output because the cost of a hallucinated data migration is catastrophic.
I agree that verification remains a human domain for now, particularly for high-stakes edge cases.
It has to be. Even as frameworks like Microsoft's agent architecture allow for best-of-breed multi-agent workflows, mixing a Claude agent for coding with another model for analysis, the human is still the only entity capable of legally and operationally signing off on the final state of truth.
That is a fair distinction regarding final verification. But I keep coming back to the broader macroeconomic picture. I look at the devastation of those SaaS stocks on February 3rd, and I see a market that recognizes an uncomfortable truth. The proprietary logic that software companies spent millions of dollars hard-coding over the last decade can now be dynamically generated on the fly by an agent team for pennies.
The market panicked over the release of OpenClaw, certainly. But markets always overreact to the threat of the unknown. They price in the absolute worst-case scenario for incumbents before the operational friction of the new technology is truly understood.
Perhaps the timeline is debated, but the underlying capability is undeniable. When I look at the $285 billion market restructuring, and I look at the successful C compiler experiment, where agents coordinated to build foundational infrastructure from scratch, I see definitive proof. We have crossed a threshold. The transition from simple generative AI to true agentic AI means we are fundamentally substituting human labor and specialized software with autonomous, distributed execution workflows.
And my perspective remains that while the paddle effect and infrastructure optimizations have made always-on agents financially viable, the heavy agentic tax cannot be ignored. The pristine vacuum of a lab experiment doesn't map perfectly to messy enterprise realities.
Fair enough. Human judgment, strict governance through the Model Context Protocol, and rigorous testing architectures are actually more critical now than ever before. We haven't replaced the human software engineer. We've just radically changed their toolkit.
Yet, despite our differing views on the ultimate role of the human, I think we both find strong convergence on one fundamental reality. The era of simple, prompt-and-response generative AI is over. Unquestionably, the days of typing a question into a chat box and waiting for a static text snippet are gone. We are now firmly in the era of parallel execution pipelines, and that fundamentally alters how software, legal documents, and data infrastructures are constructed moving forward.
Which makes this an incredibly fascinating and perhaps slightly intimidating time for the industry. Anyone trying to understand this transition shouldn't just look at the stock market. You need to deeply examine the mechanics of the Model Context Protocol.
Yep.
Understand how context compaction actually changes AI memory, and honestly assess your own organization's readiness for always-on agents. Are you prepared to govern a system that writes, tests, and deploys its own code?
It is the single most important question every data engineer, security architect, and CTO has to answer in 2026.
We're going to leave the debate there today. As always, we won't declare a definitive winner. It's up to you to look at the architecture and determine where the line between human orchestration and true AI autonomy really lies. But the next time you picture a factory floor upgrading its assembly line, ask yourself, if the robotic arms are the ones huddled in the corner holding the planning meeting, whose factory is it really?